Hi, this is your Professor Sudha Kolathuparambil. I am going to explain you the Leibniz notation, the power rule, and the sum and difference rules. Let y equal f of x, then the derivative of f we can represent as f prime of x. And using the limit procedure, we can find the derivative. Limit h approaches to 0, f of x plus h minus f of x whole divided by h. Other notations are like a y prime. We read this as y prime, okay, or f prime of x. Another common way to express the derivative of y with respect to x is writing dy over dx. This notation is known as the Leibniz notation. So this is the derivative of y with respect to the variable x. Sometimes in short form I always write derivative of y with respect to x, or differentiate y with respect to x, like that. So sometimes if I'm using any notation like that, this is actually with respect to x. And don't think that if you are writing dy over dx, you can cancel this d and it is equal y over x. That is completely wrong. Okay, you cannot do that. This is basically saying derivative of y with respect to x. So d over dx of y. Or we can write d over dx of f of x. So we are differentiating f of x with respect to the variable x. By using the limit definition, we can find the derivative of x square with respect to x equal 2x. And we can find the derivative of x cube as 3x square. Derivative of x power 4 with respect to x is 4x cube. Did you see any pattern in this? So can you predict the derivative of x power n with respect to x, where n is a constant? So this will be n times x power n minus 1. You can see that we are bringing the exponent in front of that and subtract 1 from the exponent. Same way, bring the exponent in front of that and subtract 1 from the exponent. So derivative of x power 5 with respect to x will be 5 times x power 4. So right now you learn the power rule. Derivative of x power n is n times x power n minus 1. And don't think we always differentiate with respect to x. Assume we have a formula for the compound interest a equal 1000 1 plus r over 12 power 36. If we want to find the rate of change of amount with respect to the rate, we can write dA over dr. Or if a population function is given, and if we need to find the growth rate with respect to time t, we can write derivative of p with respect to the variable t. Let's do one more example. Derivative of x power negative 1. We can apply the power rule, negative 1 power x power negative 1 minus 1, right? So it will be x power negative 2. So we are bringing the exponent in front of that and subtract 1 from the power. Another example, derivative of x power half. We can bring the exponent in front of that and subtract 1 from the power. So half x power negative half. That is half move that to the denominator so that the exponent will be positive. So here in the power rule, n is any real number. Let's do some more examples. First question, find the derivative of x power 15 or differentiate with respect to x. The question can be like that too. So since we are finding the derivative, either you can write y prime or you can write dy over dx. We are differentiating with respect to x. So apply the power rule, bring the exponent in front of that and subtract 1 from the power. So 15 x power 14. Second question, y is x power negative 7. So derivative of x power negative 7 with respect to x, we can apply the power rule, bring the exponent in front of that, subtract 1 from the power. So negative 7 x power negative 8. We can rewrite this with a positive exponent by moving this x power negative 8 to the denominator. Negative will be still there. Only this exponent, the sign will change if we move to the denominator. Next question, y equal 4th root of x. 4th root of x, we can rewrite the question as x power 1/4. Now we can differentiate x power 1/4 with respect to x and apply the power rule. Bring the exponent in front of that and subtract 1 from the exponent. So negative 1/4 minus 1. 1 we can write 4 over 4, right? So 1/4 x power negative 5 over 4. Because in order to subtract the fraction, we need to make the denominator same. Now move the term to the denominator so that the exponent will be positive. This is same as writing 1/4 4th root of x power 5. So whatever in this denominator, that is the index, and this is the power, that will be still at the exponent. Derivative of a constant function is 0. So derivative of, if c is a constant, it is equal 0. So if I'm saying f of x, that is the function, is a constant. So for example, f of x equal 2 or f of x equal 3 or f of x equal negative 4. All these are like horizontal line, right? This is the graph of f of x equal to 2. If it is f of x equal 3, it will be crossing to 3. This is the line. Or y equal 3, I can write. Or f of x equal 3 is same as writing y equal 3. If it is y equal negative 4, this function, that is also a horizontal line. So what is the slope of all these horizontal lines? The slope is equal 0. For horizontal line, slope is 0. So basically we can say slope of a constant function is 0 or derivative of a constant function is 0. So for example, derivative of 7 equals 0. Derivative of negative 1.5 equals 0. Derivative of pi square. Pi is a constant. So derivative is 0. Derivative of 10th power square root of 7. That is also a constant. So derivative is 0. The sum and difference rule. If you want to take the derivative of f of x plus g of x, it is same as taking the derivative of each function and add. The derivative of the sum is the sum of the derivative. Same rule apply for the difference. So if you are taking the derivative of the difference, it is same as the difference of the derivative. So derivative of f of x minus the derivative of g of x. So let's look at some examples. We need to find the derivative of 5x power 4 minus 7. So you can take the derivative of each one. So derivative of 5x power 4 minus derivative of 7. Derivative of 5x power 4 is same as, this is a constant and a function. So constant times the derivative of the function. And derivative of the constant is 0 here. So see the difference between, let me write down the rules here. Derivative of a constant is 0. But derivative of a constant and a function is same as writing constant times the derivative of the function. Okay. So the first one we apply this rule. For the second one, the derivative of the constant, we are applying the second rule. So 5 times derivative of x power 4, apply the power rule. So 4 times x cube. I don't need to write the 0. Then simplify 5 times 4, 20 x cube. Let's look at another example. Differentiate. So dy by dx equal. We can apply the sum difference rule. That means we are taking the derivative of each term separately. So minus derivative of 2 cube root of x plus derivative of 1/3 x square minus the derivative of square root of 7. Here this is the constant and a function. So it will be constant times the derivative of the function. So constant is 8 times the derivative of x power 5. Then minus 2 is a constant. So 2 times derivative of the function. Function is cube root of x. Cube root of x I can write x power 1/3. Then plus, here this term is constant and a function. So here this is constant, function, this is constant and function. So constant is 1/3, function is 1 over x square. So I can rewrite this as constant times derivative of the function. So function I can rewrite this again as x power negative 2 if I move that x to the numerator. So x power negative 2. Then this term, this is a constant. So derivative of a constant is 0. Now apply the power rule. 8 times power rule is 5 times x power 4 minus 2. Apply the power rule again for this. So 1/3 times 1/3 minus 1. And 1/3 times, apply the power rule, bring the exponent in front of that, subtract 1 from the exponent. And the last term is 0, so I don't need to write that. Now simplify. We are done with taking the derivative in this step. Now we are just simplifying. So 40 x power 4. If you want, I can write how I'm getting the 4 here. That is, we are bringing the 5 in front of that and subtract 1 from 5. That's how I'm getting x power 4. Then 2/3 x power negative 2/3 and 1/3 and negative 2, that makes it negative 2/3 x power negative 3. We can simplify again and write it as a positive exponent. I can move this term to the denominator, that makes it x power. You can leave your final answer like this, or you can write cube root of x square minus 2/3 x cube. In this section, you learn derivative of a constant is 0. Derivative of a constant and a function is constant times the derivative of the function. And derivative of x power n, the power rule, n times x power n minus 1. Then derivative of f of x plus or minus g of x, that is same as taking the derivative of f of x plus or minus the derivative of g of x. Derivative of x equal 1. Because this is the graph of y equal x, the slope of this line is equal 1. For horizontal line, the slope is 0. That's why derivative of a constant 0. Constant function, the graph is a horizontal line. So derivative of a constant function is 0. Derivative of x is 1.